squared plus 4 times y plus 2 squared equals 36. 11 plus 25. Is that correct?
Yeah.
Okay. Now, I mentioned before that the rules of the hyperbola only work if the entire equation is equal to 1.
So you divide by 36.
Divide everything by 36 and life will be good. Where it gets interesting is...
And I remember it was like 9 times 4 is 36, so every time you divide you're going to get 4 on the first one and then 9 on the second one.
Yes, they will often set up the problems like that. Yeah, the good news is you're going to get mostly problems that are designed to work out really, really well. Bad news is that means your next test will be mostly without a calculator. So, I divide both sides by 36. 36 divided by 36 is 1. 9 divided by 36 gives me a 4 on the bottom. It's actually 1/4, but it's on the bottom there. 4 divided by 36 will give me 9 on the bottom. And now we can say that we have an ellipse with a center
at
1, -2. Very good. A is 2. B is 3. The foci is going to be at something really annoying, root 5. Very good. Because, yeah, it's going to be c squared equals b squared minus a squared. So c squared will be 9 minus 4. So c is going to be the square root of 5, which is about 2 point something.
It's going to be a long test.
Or does that have like 3 problems on it? So.
Wait a minute.
We did all that to get to that.
Yeah, now we're ready to graph it. Yeah.
That.
But it's not that. It's not that.
Look at it, people.
There isn't one for this.
Look at it.
No, but it's not that long.
All that
We just, like,
to get to where they
Yeah.
gave us.
And it's going to get longer when next week we're going to start talking about when you rotate these conics.
Rotate
Yeah.
the conics.
That's very good, nice special effects. So if I ask you to graph this, I will do this fairly quickly. And let's see, center, 1, -2. Okay, Stewie or a egg?
Egg.
Egg.
Egg. So from here, I only go up. Hang on, I need to change my scale. This is way too small. Okay, so here's 1. Here's -2. From here, I go up just 3. 1, 2, 3. So this will be the point 1, 1. From here, I go down from -2. -3, -4, -5. So this will be the point -1, -5. I go left and right 2. So from 1, I go out to...
+1, -5.
Thank you. Thank you, Parker. You're on fire today. I love it. So this is the point... help me out here. I'm starting here, so now I go over 2. So this is the point 3, -2. Double check me. And then over here, I should have the point...
-1, -2.
-1, -2.
Oh god, this is gonna be crap. Just watch, people of YouTube. You're doing this to the world, mister.
Wow.
Look at that. Let's zoom in.
Middle
Oh my god.
Seriously, that's terrible.
Look at that lump on the side.
Okay, yes, thank you. Ramsey, I can... There's enough.
My name's Ramsey.
Okay,
from Jam.
so...
Wait, can you like redraw that line? It's really annoying. Yeah, it's like,
Which one? This one?
yeah.
Is your graph slanted?
Yes.
The actual line goes like
My actual...
this.
Yes, my actual axis is slanted.
No, it goes like this. It goes.
Yes, thank you, Parker. Okay, so... this is terrible. Anyway... Sprute 5 is in between 2 and 3, closer to 2. So from here I'd go up 1, up 2, and somewhere around here is going to be one of my foci. And down here, a little lower than -4, is going to be my other foci. Some things to check. These 2 points should have the same y value. These 2 points should have the same x value of +1. Foci are on the major axis. We started with this equation here in standard form. And we wound up with that hideous but well-labeled graph over there. Oh, I forgot to label my foci.
And your axes.
And my axes, thank you. So, my This foci would be the point 1 comma negative 2 plus root 5.
Oh god.
And this foci down here would be 1 comma negative 2 minus root 5.
Would these be calculator tests?
No?
What if we have to figure out what root 5 is?
Let's see. Root 5, let's see, 5.
Okay, not root 5, like root,
13.
72.
I guess it's just in between, so you're not going to go higher than, 15 squared.
No. I firmly believe, kids, at this point, you guys should know all your square roots up to 15.
What?
We did that last year.
Yeah.
I know them up to like 10.
All right. We'll work on them. Other things you should know. So, it'd be a little bit annoying. You'd have to scale it, but what's about the most annoying thing I could do with this? So really, something reasonable would be like root 450. This is like as unreasonable as I would get, because I figure you should know that's 2 times 225, and that's 15 times 15.
What?
That's a little...
It's a bit much. So this you should know is 15 root 2. And root 2 is between 1 and 2.
I will come up and hit you.
So this is between 15 and 30. That's really kind of a big range,
If you did
isn't
like
it?
225, if you did like root
So-
132, then we know it's in between like 11 and 12, I guess.
Yes.
But then, so do we just graph like 11.5-ish?
Just in between 11 and 12, yeah. Some of them should be... Yeah, I like to see that you know that root 5 is closer to 2 than 3, because 5 is closer to 4 than 9. But it's not a linear progression. You can't go by the middle. Roots don't work that way.
Where's the negative 2 if it's like positive 1?
I'm sorry?
The foci?
This foci, yes. Negative 2 plus root 5 is going to get you a number bigger than 0. Root 5 is a little bigger than 2.
And how do you know it's like negative 2 plus root 5? If you only got root 5 for the...
Okay, we got root 5 for the C.
Yeah.
This is your C is your distance along your major axis from the middle.
Okay, I get it.
So yeah, it's how far you go up and down from this point.
Yeah, I get it.
If it were Stewie, it'd be how far you go left and right from that point. Any questions on that? Other questions? You guys got an idea of the expectations?
Yes.
You know, a really easy way to avoid all these questions is to let us have a calculator. Yes, said Mr. Bellavo.
So no fun.
As he said,
It
nod.
wouldn't be that helpful because you could just write down.
Calculators can't graph ellipses, can't graph conics directly.
Right. No, it would
They
be.
can't?
No.
But they have all the
Yes.
formulas.
You notice when you hit y equals, you get a y equals. That means only functions. This isn't a function.
But you know what? But on my awesome calculator,
Not directly.
on
you
the
have to cheat. We
TI-84
have to go
Plus
into
Silver
parametric
Edition,
mode.
you can go to Applications and go to Conics, and then go to.
Interesting. Okay, guys, the homework is online. It's page 8.